Hello students, in this class we will discuss about the battery. So generally we know the importance of the battery. It is very useful in our daily life, and without battery we can't expect our human life, right? Here the general definition, a battery is a device that stores chemical energy and converts it to electricity. Simply. Generally, you know about the battery, generally it will gives the supply. Generally it will gives the supply. For example, we have some car is there. In children's generally we use some battery here inside. Inside battery is there for any working. But inside the battery, it stores chemical energy. It stores in the form of chemical energy. Don't forget it. That chemical energy is converted into the electrical energy. Any battery. Why? Why it is stored in chemical energy? Chemical energy storing is easy. Then converting from chemical to energy is chemical to electrical energy is simple. But electrical energy, storing of electrical energy is difficult. It is not possible. It is not possible. So in battery it stores means it stores in the form of chemical energy only, not electrical energy. That's why the definition is a battery is a device. Battery is a device that stores chemical energy and it converts it to electricity. Converts it to electricity. Reason is chemical energy storing is possible. Electrical energy storing is doesn't possible. Here types of batteries are two types we will discuss here. First battery is primary battery. Primary itself it's a first battery. Primary batteries can be used only once because of the chemical reactions is that supply the current are irreversible. That means, so in this battery, initially we will take, we will store inside it. It will store the chemical energy. Chemical inside it has the chemical energy. Whenever it connected to some load, that will be becomes the electrical power, electrical energy. But again, the electrical energy converted into chemical energy is not possible in case of these primary batteries. The primary batteries are can be used only once because of the chemical reactions that supply the currents are irreversible. Current reversible is not possible. Once the battery is charged, at one time it will be useful. In this type of batteries, it not possible to again store it. Right. Primary batteries are most common batteries available today because of its their low cost and simplicity use. So generally these are the very low cost and simple to use. That's why these are very much useful. Carbon zinc dry cells and alkaline cells dominant portable consumer batteries applications. So generally if you observe these batteries, if you read the formulas behind it, generally the formula is like this. The formula is carbon zinc dry cell. Why dry cell? It's like it doesn't have fluid. It's in the form of chemical, in the form of dry. That means in terms of powder, if you open these batteries, you will get a black powder. That is chemical generally. That's why that is carbon zinc dry cells and alkaline cells, or this is also a cell. Alkaline cells is dominant portable consumer is dominant portable consumer battery application. Therefore current are low and current is low and usage is sporadic. That means usage is sporadic means limited. Only it has only limited use. Other primary batteries such as those using mercury or lithium based chemistries may be used in application when high energy densities, small sizes, long shelf life are especially important. Remaining we have another batteries. One is the mercury battery. We have mercury battery. Another one is the lithium based chemistries. These are the different type of batteries, but it has high energy density. It can supply the high energy to the load and very small size, and it has long life. So that's why these are the somewhat better useful in primary batteries compared with the carbon zinc and alkaline cells. In general, primary batteries have dominant in two areas. So generally they are very much useful in two areas. Consumer products, where the initial cost of the battery is very important. Electronic products such as watches, hearing aids and pacemakers. So generally these are, in two areas it is dominant, where the low initial cost, we require a batteries but we have to invest a less cost. These primary batteries are applicable. And in electronic products, generally, in the watches, in the wall clocks and the wrist watches, we have used the small batteries. So generally this type of battery used, right? Hearing aids means hearing phones, that means like that. And pacemakers are so one of the application where drains are low and recharging is not possible. There is recharge is also not possible. So these are the primary batteries. Simple thing, primary battery means once it recharged and it is converted into the electrical energy. After discharging of the power from the battery, it is not useful. It's again not possible to recharge the battery. These are the primary batteries, simply. Next, secondary batteries. So name itself, secondary batteries. Secondary batteries are sometimes called storage batteries. The another name is the storage batteries. Name itself, it stores. Simply, name itself, it stores. Storage battery means name itself, it stores. Or accumulator. Accumulator is nothing but, so both are same. Can be used, recharged and reused. So it is recharged, again it will be reused. In these batteries, the chemical reaction that provide current from the battery are readily reserved when the current is supplied to the battery. So this type of batteries, chemical reaction, current from the battery readily reserved when the current is supplied to the battery. Simply, these type of batteries are simple method. When when it is in charging mode, in that condition, charging means electrical power is converted into the chemical power, chemical energy, it will be storing. So when the case of discharge, when it is discharging is possible, that chemical energy or power is converted into electrical power or energy. So one is possible and two is also possible. The process of inducing the storing energy in accumulator is called the charging. A simple name itself, inducing, the process of inducing or storing energy an accumulator is called charging. So this is called charging. And the process of giving out energy in the form of electric current is called discharging. So after storing the battery will be, so we have some battery, this battery is stored by giving the electric supply. After that, this battery can be used as the load, for you can use for any load. This is the discharging process, simply. Accumulator or storage batteries are owe their name secondary. These batteries called as secondary due to the fact that they can supply electrical energy only after they have been recharged. First they have to charge and again recharge. That's why they are called secondary batteries. First is charging. So next, second is discharging. That's why it is called secondary batteries. Secondary batteries, which are rechargeable, have traditionally been most widely used in industrial automotive applications. These are recharged. That's why these are very much applications in industrial as well as automotive applications. These are the two applications, industrial as well as automotive applications, like that. Okay, second batteries are simple. First it will charge the from the electrical power from the supply. It will take the electrical power and stores in the form of chemical energy. When discharging process means is giving supply to the load. For example, in our homes we are using the inverter, simple inverter. When the inverter power is there, it will stores in the chemical energy in the form of liquid. After that, inverter, when the power of supply is off, this chemical power is supplied to the electrical power to the home. Understand? Yeah. So why it is inverter? It stores in the form of DC. DC is converted into AC. That's why it is called as inverter. Right. Only two rechargeable batteries, battery chemistries, lead acid and nickel cadmium have to date achieved significant commercial success. So we have number of batteries, but two batteries are very important. The first battery is the lead acid battery, and the second battery is the nickel cadmium batteries. Are up to date, they are very successful. There are several types of secondary batteries given below. We will discuss. We have more number of batteries here. First battery, lead acid batteries. Name itself the lead acid batteries. So inside, why it is called lead acid? We are using the liquid chemical process is lead acid. We are using inside the lead acid. That means in inside we have the lead acid. What happened this lead acid when when the charging process when the charging process it will store, and when the discharging process it will deliver. Simple. Stores in the this lead acid will stores in the electrical energy in the form of chemical, and this chemical energy will convert it into the electrical. Understand? Electrical, right? Lead acid batteries, according to the service rendered by them, are classified into automotive, motive power, stationary batteries. So depends on the service of these batteries, we can divide automotive battery and motive power battery and stationary batteries. These are the three types of batteries. Next, the most important battery is nickel iron or Edison battery. The another name of the nickel iron battery is Edison. Edison is the scientist name. That's why we will get the Edison name. These batteries are going to become more and more popular as there is a possibility of their development into high energy density batteries for electric vehicles. These are very much high energy density batteries. So now recent trend is electric vehicles. You know how the electric vehicles are most popular nowadays. In order to reduce the pollution, in order to using of the fossil fuels, we are using the electric vehicles. In that, nickel iron batteries are more popular. This diagram is for the nickel iron batteries. Next, nickel cadmium accumulator. Nickel cadmium accumulator is also a rechargeable battery, but this battery is in the form of powder. That means chemical. It's look like a chemical powder. Inside we have the chemical powder. That chemical powder is nickel cadmium. Okay, now inside the nickel cadmium is the chemical powder. Next, nickel metal hydride cell. Next is the nickel metal hydride cell. This is the nickel metal hydride cell. So these are the different secondary batteries. Look at first battery is simple carbon, zinc and alkaline cells. Look at here. This is the first battery and this is the second battery, most popular batteries. And in secondary batteries we have lead acid battery and nickel cadmium battery, lead acid and nickel iron, nickel cadmium, nickel metal hydride cells. These are the most popular batteries in secondary batteries. So in that we will discuss two batteries. Those are lead acid batteries and nickel iron batteries are most popular batteries. So when we are discussing this, we will understand how it charges and how it discharges generally. So first battery is lead acid battery. This is typical charge and discharge curves. Variation in terminal voltage of lead acid accumulators are as follows. So the charging and discharging curves are looking like this. So this is the terminal, y-axis is the terminal voltage of the y-axis is the terminal voltage of the battery, and this is the time in charging or discharging is the time. Generally, look at it. When the cell is charged, the voltage of the cell increases from 1 volt to 2.2 volts. Look at, generally the cell is 1.8 volts generally. When it is charged, it is the voltage is starts from 1.8 and increases to maximum voltage of 2.2 during first 2 hours. So for the 2 hours it is 2.2, then increases very slowly, rather remain almost constant for sufficient time, finally rises to 2.5 to 2.7, and after that, after the increasing, it will take, look at here, it will reach 2.2 in 2 hours, but from 2 to 10 hours, the within 8 hours it will starts from 2.22 and 2.7 or 2.8, 2.5 to 2.7. So that means it will take 8 hours of the time to decrease its terminal voltage from 2.2 to 2.7, 2.2 to 2.7. Charging, this is charging means simple point you have to understand. Charging means the terminal voltage, generally no charging it will be 1.8 volts. The terminal voltage of the battery will be increases from 1 point voltage to 2.7 volts, and in order to increase this it will take almost 10 hours of the time. This lead acid battery will take the 10 hours of the time, right? Caution, the cell should never be allowed a discharge beyond 1.75 volts. So it is discharging generally, but cell never has to discharge from less than 1.75. The discharging capacity is last 1.75, right? Otherwise lead sulfate will formed on the electrodes, which is hard and insoluble and increases the internal resistance of the cell. So generally, the whenever discharging, maximum discharging point, whenever discharging, max minimum terminal voltage is 1.75 volts. This is 1.75 volt minimum terminal voltage. So after this, after if it is less than 1.75 volts, what happened? Sulfation is formed. Sulfation is formed. Whenever the sulfation is formed, the internal resistance in the battery will increases. Internal resistance increases means the battery storage capacity is decreases, right? That's why the minimum point is like this. Whenever charging will reaches like this, whenever we are discharging period also follow this path, and discharging period from 2.2 to 1.8 it will take the 10 hours. In the 10 hours it will be decreases, right? So this is about the charging and discharging curves of the lead acid battery. Okay, this is the characteristic of the lead acid battery. Next, nickel iron or Edison batteries. So in this also we will discuss charging and discharging curve. In this, the minimum point of the nickel iron battery terminal voltage is 1.4 volts, and it is whenever you are charging in 7 hours it will reach, charging in 7 hours it will reach 1.42 1.2, 1.9 or 2 volts are the maximum. And when it discharging is, it will take 1.2 to 0.8 volts. Okay, 0.8 volts. Here the EMF when fully charged is about 1.4 volts, decreases to 1.3 rapidly, then slowly to 1.1 to 1.0 of discharge. When it fully charged, 1.4 volts, 1.2 to 1.3 rapidly, then slowly 1.1 to 1 discharge. It slowly discharges. Okay. An average discharge voltage is about 1.2 volts. Averagely, it will discharge the voltage of 1.2 volts. The average charging voltage is 1.7 volts per cell. So it will charging the 1.7 volts per cell. The voltage characteristics are similar to the lead acid cell. If you observe this, the characteristics are similar, but the only thing is it starts from 1.8 and end at the 2.7, and it starts from 2.2 and end at the 1.8, right? There is no lower limit to the voltage to the Edison cell, because there is nothing like sulfation. Sulfation means, so in the lead acid batteries the internal resistance will be increases, but there is no increases. But discharge is not continued below a useful lower limit, but discharge is, it will be a particular limit. But in that we have a difference. It is discharge is only up to the 1.8, but there is no limit. The EMF of the cell of battery increases slightly with the temperature. Here, by increasing the temperature, the EMF cell is increases. Due to comparatively high internal resistance, the efficiency of the Edison batteries are lower than the lead acid batteries. Compare with the efficiency, nickel iron batteries have less efficiency compared with the lead acid batteries. That's why lead acid batteries are very efficient. The ampere hour and watt hour efficiencies of the Edison batteries are about 80% and 60% respectively. So these efficiencies we will discuss in the before topics. So we have some more topics after this topic. We have these ampere hour and watt hour efficiencies. So here the efficiency is also important point, that is ampere hour is 80%, this watt hour is 60%. Average energy density is about 500 watt hour per kg of cell. So this is also important thing. These nickel iron batteries or Edison batteries have energy density, energy per unit area, 50 watt hour per kg cell. If you are using a kg cell, it will have. When assembling a batteries for the same voltage, number of nickel iron cells required more than that of lead acid cells. Lead acid cells required only less. Cells means, so we have more number of cells will gives the one battery. So in the example we will discuss here. For example, a 12 volts lead acid battery will require 12 by 2, 6 series connected cells. That means so in order to form a 12 volts battery, how we are arranging, this is the one cell, and 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 this is the one cell. 1 2 3 4 5, this is the one cell. Each have the 2 volts, 2 volts, 2 2 2 2. This is the plus minus plus minus plus minus plus minus plus minus. This is series connected. So if you adding this voltage, you will get the total voltage of 12 volts. Total voltage of, this is the cell method. So battery is designed in this cell method. Okay. For example, a 12 volts lead acid battery will need 12 by 2, 6 series connected cell. Whereas in nickel iron batteries will require 12 by 1.2, because it has only 1.2 volts capacity. it is only for lead acid, it is only 6 cells are required. But in case of nickel iron batteries, it require how many series? 10 series. Same voltage of 12 volts, because here each cell supplies 1.2 volts. Look at here. This each cell supplies only 1.2 volts. But in that each cell supply the 2 volts. Right. Applications. These batteries are used for the propulsion of industrial trucks and mine locomotives. So generally industrial trucks you know that. Industrial trucks means generally which, so any truck will give lighting. Inside lighting we have the batteries is there, and to start the engine starting also batteries. Not only truck, in our bikes, so for example in the bike, in order to auto starting of the bike, so without kick we have to start the bike, we require the battery. Bike which purpose? The battery requirement is for auto start and lighting. So battery is required, otherwise it's not possible. And mine locomotives, in the mine locomotives also these batteries are, by using the batteries it will be run. For railway car lighting, in railway cars are to provide the lighting, it is useful. And air conditioning, in railways car lighting and air condition, these are useful because of their rugged construction and the advantages. They have the rugged construction, they are very rough material and more advantages. These are the applications of the nickel iron batteries as well as lead acid batteries. Okay, so these batteries, generally we are using these batteries, lead acid battery, nickel iron batteries. Once again you look at the physical diagram, though this is the lead acid battery, so you can observe here in our homes we will use this. And nickel iron batteries are very much popular in electric vehicles and we are using. These are the voltage levels. Okay, this is about different batteries, primary batteries and secondary batteries, their voltage current characteristics of two important batteries, that is one lead acid, another one is the nickel iron. Okay, thank you.